Welcome to Supercharge your GKE development workflows with IDE extensions. My name is Ian.
Hi, everyone. I'm Etan.
Before we get started, we'll do a little quick about us.
So my name is Etan. I've been at Google for about 3 years now. I work on the Google Cloud Platform. Currently, I'm the technical lead for Cloud Code for IntelliJ. And in my spare time, I enjoy traveling and doing some snowboarding.
And my name is Ian. I also work on the Google Cloud Platform. I've been there for about 6 years, and I'm based out of Seattle. I'm the technical lead for Cloud Code for Visual Studio Code, which is a partner effort to what Etan is working on. I also like to travel, but instead I've pictured my dog here, who I think is adorable. So, Cloud Code. Etan and I both said it. What is it? So Cloud Code is a set of integrated tooling that aims to make working with Kubernetes and cloud-native applications easier. We want to make that development process simpler. We know it's hard. We've seen people work with it. They struggle. There's a lot of moving pieces. You have your YAML. You have worrying about the statefulness of your application, and then your code. So what we've done is we've tried to break it up into a couple different portions. We kind of have something for the developers, and we have people on the DevOps side. And we understand that there's overlap, and of course, you'll probably end up using both parts of these tooling. But what we have for the developers, so who in the audience here, your primary job is writing code, you're a developer, show of hands. All right, a lot of developers here, good. So we got some good stuff for you. So what we try and do is we understand that working with Kubernetes means you have to work with a cluster. But a lot of the times you just want to be writing code. So to make it easier, we try and make it as close as possible to your local development experience. So when you're working with your code, you're writing code, and then in the background we handle building your image, building your application, pushing it off to your GKE cluster or your Kubernetes cluster, whatever you're working with, and it's there when you're ready to check it out and work with it. On top of that, the debugging, we've tried to simplify that. We make it easy. If you have a pod selector, you can very simply just debug a remote cluster, no problem at all. And then on the DevOps side, who's a little more on the DevOps side? All right, we got a lot of DevOps in here too. You're going to see some pretty cool features. So we give you some support in the IDE to help you understand the state of your application, see what things are live and what's not, if there's issues, view events that have happened recently, and on top of that, easily diagnose issues. You can use the debugging, but also look into the logs and other things. We also give some great tooling to help making the YAML a little easier to consume and able to go back and forth from what's local on your machine, the YAML you have there, against the server YAML. So Etan now is going to give us a little bit deeper dive into some of the features we have to offer.
All right, thanks, Ian. So before we look a little bit closer at some of the features that Cloud Code has to offer, just to get an idea of what people here are using in the room, if I could get a show of hands, how many people here use VS Code on a regular basis?
Nice.
Wow, a lot of you. And what about JetBrains or one of the other JetBrains or IntelliJ-based IDs? OK, cool. And then what about something else, some other editor? Okay. Makes sense. Nice. All right, so let's take a closer look at some of the features of Cloud Code for IDs. So first of all, the inner development loop. What is that? So imagine that you're tasked with building an application or a microservice that needs to run on a Kubernetes cluster. One of the first things you might want to do after figuring out basic tasks, like firing up your favorite editor, setting up version control, and so on, is actually running your application. So opening up a web browser, hitting the endpoint, assuming it's a web app, and then verifying and making sure that everything works as intended, and then iterating on your code. So in other words, setting up that inner development loop. Now, since your application is going to be deployed to a Kubernetes cluster, it's probably pretty important that your development environment mirror production as closely as possible. This means running on an actual cluster. Now, this could be a local cluster like Minikube, or a cluster on Docker for desktop. Or if you have the resources available to you, it could be on a remote cluster on one of the cloud providers, like GKE on GCP. Right. So if you've ever tried to set up this process manually, you know it's not such an easy task. You have to figure out how to build your container image, tag it, push it to a container repository, update your manifests, deploy everything, and then repeat this every time you change your code. All of this while you're trying to focus on writing your code and getting your business logic working properly. So we think the IDE is a good place to try and tackle some of these problems because we all know that context switching can really kill productivity. So our tooling will help here. We'll create new targets for you in the IDE in the form of new commands in the command palette if you're a VS Code user, and new run configurations if you're an IntelliJ user that will help you with a single click set up this development workflow. So the tooling will take care of building the image, pushing it out to a repository, deploying your application. And the tooling will sit there and watch for changes in your source code, and then surface it live on a cluster every time something changes, so you can quickly verify your code. And again, let me stress, this can be any Kubernetes cluster. So it can be a local development cluster, or it can work on any of the cloud providers. And when you're done with development, the tooling will take care of cleaning up the deployed artifacts for you. So much like the feel of a local development server, but with the power and the fidelity of running on a real Kubernetes cluster. All right, next, debugging. So at some point, inevitably, you're going to run into issues with your application. So at this point, it's probably really important that you be able to set up a debugger. So this means setting breakpoints, stepping through your code, viewing the call stack, local variables, being able to run expressions, and so on. But remember, our application now is running inside of a container and on a cluster somewhere. So setting this up manually is not really that trivial. You have to set up the proper language-specific debug configuration, inject that properly, setting up the environment variables, doing the port forwarding, and attaching a remote debugger. Our tooling will help here. Again, with a single click, you'll be able to set up a debugger and attach it to your service or even your set of microservices, and debug your application as easily as if it were running locally. Cool. So now you can set up your development workflow and you can debug your code. One thing at this point that might be interesting to do is gain some insight into the state of your cluster. So this means digging down into the resources, checking to see if your pods are healthy, maybe streaming logs from a container, or even viewing remote YAML to make sure things are there as you expect them. And our tooling, again, will help here in the form of an IDE resource browser. So at some point, you're going to want to expand your application, add more features, add more functionality. And this probably means more configuration, more YAML. Our tools will help you work with this by providing templates and editing support. So things like auto-completion and quick documentation. All the things you'd expect from an editing experience inside of an IDE. We also have integrations with popular tools and libraries. A couple examples. First, Skaffold. Skaffold powers much of the inner loop experience in the deployment that I talked about. And in the demo, you'll see us dig in a little bit into the configuration there. Jib. You'll see this in the demo too. Jib stands for Java Image Builder. So for you Java developers out there, Jib is a tool that helps you easily containerize your Java applications. You don't need to have Docker installed. You don't even need to write a Docker file. All you need to do is drop in a snippet into your pom.xml or your build.gradle, depending on what you're using. Lastly, we have some key integrations with the Google Cloud Platform products, and I'll give a couple examples. So the first one is an API browser. In the demo, you'll see that we're going to be using the Google Cloud Vision API to extract some features from a book image. With the API browser, inside the IDE, you'll be able to discover available APIs, like the Google Cloud Vision API, add the associated client library to your build automatically, and even do things like enable the API on your cloud project and set up authentication, like creating service accounts, attaching roles to it, so you don't have to switch over to the web console. Great. So I'm going to hand it off to Ian now to kick off the demo.
All right, so hopefully at this point you guys aren't sick of us talking yet. We're going to talk for just one more slide real quick to give you, oops, let's go the right direction there, to give you a quick overview of what we're going to demo on our application so you have an idea about what we're doing when we're talking about it. So you see this kind of square with rounded edges there. This is just a cluster. And in this case, we're going to be using GKE. But you could realistically use anything. It just needs to be a Kubernetes cluster. Etan's going to use Docker for desktop. You could use Minikube. You could use a cluster on Azure, AWS. It really doesn't matter. It just needs to be a cluster. And in that cluster, we have two kind of sets of service. You see the bookshelf, which is just a bookshelf application. You can add a book to it, and we'll talk a little bit about that later on, as well as an image recognition service. And what that does is it does some smarts to make our bookshelf application a little bit cooler. The bookshelf app is talking to some data services on GCP to help us store some data. And the image recognition service is also talking to some APIs around vision and some books, which pretty cool API to get some information about books. So that's just a quick high-level overview of what's happening there. And now we're going to go ahead and jump over to the demo. Cool. All right, so we've got VS Code here. So it looked like most of you in the audience here were VS Code users, but quickly I'll explain for those of you who aren't. Command-Shift-P or Control-Shift-P is going to open up the command palette. So we're going to be using that throughout the talk, and that gives you a list of commands you can access and run. And for the instance of this talk, we have Cloud Code. And these are all the contributions that we've made that you can use in the browser. So for instance, if you're a new user, you don't have a cluster, you don't have code set up, we can help you get started. And we can start out by say, I want to create a cluster. And I'm just going to type create cluster. And we can see here, I can easily, in the IDE, I can create a GKE cluster or even AWS or Azure. So if I want to create a cluster, all I do is pop into here. I'm going to fill out some basic information and then hit save. I'm not going to do this right now. It'll take a few minutes to go. We already have a cluster set up for us, but it's pretty simple. Excuse me. So once we have that cluster created, I don't have anything. Again, I can use the command palette, and I can say cloud code, new application. And what we have here is a set of examples of some simple applications. We have Hello World and Guestbook. The Hello World's a very simple one-service microservice application. And then the Guestbook is a couple microservices that's just a guestbook. You can go in, you can write your name and a message, and it'll save it there. And we have support for Python, Go, Node.js, Java, .NET Core, just to make sure that you can start in a language you're comfortable with. So if we go here, we'll start with the guestbook Node.js, just to give you an idea of what's in this application and kind of how you can get set up. So we have the .idea folder for the IntelliJ users, if you want to start there. And we have the .vs code folder for the VS Code users. And we have everything set up for you. We have the launch.json, so you can see here's how we're doing our debugging. Here's our debug configurations. And then we have some Kubernetes manifests, some source. It's a pretty simple application. And then lastly, the last cool thing here we have is that Skaffold file. So Etan mentioned Skaffold earlier, and this is the engine that's kind of powering a lot of deployments. And we'll dive a little bit more into this file a little bit later on. So let's go back to my application. And so this is that bookshelf application that I mentioned before. So it's similar to the guestbook. It has a similar structure. They were actually based off the original sample. So we have it here. Let's just go ahead and deploy it. So I'm going to go back to the command palette, and I'm just going to say cloud code and deploy. And we see here we have two different types of deployments. We have deploy and continuous deploy. And continuous deploy is what Etan was talking about. This is the deployment. When I hit deploy, I'm going to deploy to my dev cluster. It's going to do a deployment, and then it's going to sit and wait. It's going to wait for me to do changes to my application, so I don't have to worry about it. You see it building the image. It's pushing it. And already, it's rolled out, and I can go view that endpoint. So I'm going to go view it, and here's my bookshelf application. So I'm going to go ahead and add a book just to give you an idea of what happens here. Let's go ahead and say the title of our book, Kubernetes Up and Running. Who's read that before? OK. You guys should read that book. It's a really good book. It's written by Kelsey, Brendan, and Joe. I don't really remember when it was published. The description, if I remember, it was a super cool book. And then we can choose the image, the cover image. So here's the cover image, Kubernetes Up and Running. And I'm going to hit OK, and then I'm going to save it. And then like that, we've got our book. And we can go back, and we have our bookshelf. That's pretty cool. I've got my description. When I click into it, I have a little bit more stuff. So me, being the book lover I am, I'm going to go back to VS Code, and I'm going to say, every time that I upload a book, I want the description to say, Ian really likes this book. If I could spell, there we go. Typing in front of people so hard, right? And as soon as I hit save, we can see here that we've already kicked off another build. So I'm not doing anything. I'm saving my code, I'm working, and the deployments are happening. Now, what I want you to remember is that this is not local. This is happening against a GKE cluster. So it doesn't feel like I'm having to do anything special, and I'm just working with that deployment remotely. So while this is building, I'm going to go ahead and go back to that Skaffold file like I promised you. So here's the Skaffold file. And so what we have is we have a default deployment at the top, and then we have profiles. And we can think about profiles, they're kind of like environments. So we have a dev environment and a QA environment. And you can see here our build artifact, when we do nothing special, we're just going to use Docker to do these builds. And then we have a deploy step, and we're using kubectl. We can actually do other things like kustomize and Helm in here. And then we have the manifest we want to use to build it. When we jump down to QA, again, we have that same build. here, but now we're using Google Cloud Build. So we're using Google Cloud Build. We're going to build our images off from the server to give us a little bit more reliable, consistent deployment when we're working with our QA. And again, you see down here we have another deploy definition. And at the top, we're using dev here and QA down here at the bottom. So now it looks like my application has been deployed. So we'll go back over here. And I'm going to go back to the books. And I'm going to try and add another book. We'll do Kubernetes up and running again. I still don't remember when it was published. Hopefully, we can figure that out later with something Etan will do. And then I'm going to go and use that again. Great. So now, every time, I also added, Ian really likes this book. And of course, I didn't add a space. But you can see here how easy it was for me to change my application, change my code, and just deploy right away. So what Etan did, as we talked about in the beginning, was image recognition service that he wrote. So being the semi-lazy engineers we were, we didn't want to have to type all this stuff in. I can't remember when a book's been created, published. I probably can't spell the author's last names. So I'm going to go with this, and we call this the auto-awesome feature because we think it's pretty cool. And all I have to do now is I have to go to that book, and I open it up, and it'll pull all the information it needs from Cloud Vision. And then it can grab additional information from a Books API. So I'm going to hit save. And this is going to take a little bit longer than normal because it's calling some extra APIs in the back end, taking some time to process the image. And now, of course, now that I'm sitting here talking to you, I realize this is probably taking a little bit longer than it should. So I'm going to go ahead and stop this request. Go back to my bookshelf. OK, we still have the 2 books we had before. But something's not right. So now's a good time to demonstrate our debugging capability. So we're going to go over to our debugger. And all we're going to do is we're going to hit debug. And this was that launch.json file I showed you guys originally. And just like that in our terminal, there we go. And the debugger's attached. 1 click, a matter of seconds. We handle all the port forwarding for you, making sure we're selecting the right pods and everything. So let's go ahead and go to this is right here, the method that happens when we do our post request to add a book. And I'm just going to start adding a couple of breakpoints in here and see if we catch anything funny. There's the auto-awesome feature you can see in the code. And just to be safe, let's catch all-cut exceptions. All right, so I'm going to go back here. I'm going to try that again. Auto-awesome, add my book, and I'm going to hit save. And just like that, we hit a breakpoint in our application. So again, one more time, this is all happening on a remote cluster, and it doesn't really feel like I'm doing anything different. So we'll start stepping through this and see if anything's happening. OK, it was created by an anonymous user. That's fine. We weren't signed in. We have a public image URL. That's great. I probably should remove that before I deploy to QA. I don't think our QA engineers will like that. And let's see here. We're inside the auto-awesome feature. And just like that, unable to open a file. And we can see up here, because I turned catching all uncut exceptions on, we have a failure. Request to image rec 8080 failed. So that's because I'm working in my local development cluster, and it's just my cluster. No one else has access to it, and Etan hasn't deployed the service he wrote to it. So we kind of know what the issue is. Our auto-awesome feature isn't working because it's just not there. So I'm going to go ahead and I'm going to stop this debugger, and I'm going to do a quick deploy, a single deploy to our QA cluster. And while that's kicking off, I'm going to go ahead and let Etan take over, and hopefully he can create the right image recognition service, and we can link the 2 up and have a great product. Thanks, Etan. To you.
Cool, great. Can we switch over to demo 2, please? OK, there we go. So I'm going to switch over to IntelliJ right now. I have IntelliJ IDEA open. I happen to be using Java to build this service. Let's go into configure plugins really quick. So you can see here we have the Cloud Code plugin installed. This is now publicly available in the marketplace. And just to point out, this works with all of the JetBrains IDEs. So if you're a Python user, for example, this will work with PyCharm, Golang. So I started working on this service before the demo. And I have it deployed to cloud source repositories, which is Google's hosted Git repos. So I'm going to clone it from there. I'm going to clone the repo from there. Let's clone it into a local folder. It's called ImageRec. I'm going to clone it. OK, so it's cloning it right now from cloud source repos, and it's prompting me to open the project. There we go. So the project is now open, and immediately you can see a couple prompts. So this is a Maven project, and it detected a POM, so I'm going to add it just so that everything syncs. And you can see another prompt here. it detected that this is a Kubernetes-ready project, and it's prompting me to create a couple of run configurations. So I'm going to accept that. And then immediately here, you see a couple new targets available. And these are analogous to the commands in the command palette that Ian showed you earlier in VS Code. We have deploy and develop. Deploy does a single deployment to Kubernetes, and that's it. Develop runs through the whole pipeline, deploys your application, but then stays open and watches for changes in your source, and then redeploys every time things change. We'll see that in a second. So let's just quickly look at the structure of this project. So like I said, this is a Maven project. Happens to be a Spring Boot app. We have this Skaffold YAML here. Ian got into it a little bit. We have the build strategy defined here, pointing to our artifacts. We have the deploy strategy here as well, using kube control and pointing to our Kubernetes manifests. So we have a couple manifests here, one used for dev and one used for the QA environment. The dev adds some secrets for mounting the service account to access the remote API. So let's look at our source. So we have a simple controller here. Let's first set up the JDK so everything resolves. There we go. So we have a couple endpoints here. So we have an image endpoint. This is the endpoint that the bookshelf application is going to hit. And then a couple debug endpoints that I'm using just to show you what's going on in the application. We'll see that in a second. And we have a service here called the default feature extraction service. And this is the service that's responsible for calling out to the Cloud Vision API as well as the Books API to do some extraction from the book image. And you can see there's a lot of class path issues here. These all look like classes that are part of the Cloud Vision API. That's OK. That means that I can show you some other features now that we have. So I'm going to quickly go to Tools, then select Cloud Code. We have a couple actions here available to us. Right now, I'm interested in this one. So I'm going to click Add Cloud Libraries and Manage Cloud APIs. So we get this API Explorer that I talked about earlier. And in particular, right now, we're interested in the Cloud Vision API, like I mentioned. So I'm going to select that. We get some information about the API, links to documentation, and so on. Let me select the cloud project. So in this case, we're working with the Bookshelf application, Bookshelf Next 2019. You can see here that it's going to add it to the main module, the ImageRec module. And it's going to use the latest BOM. And what that means, it just means that it's going to pull in the latest version of the client library, so the Cloud Vision client library. And you can see some other things here. So by default, I have selected to enable the API on the Google Cloud Platform. So I'm going to keep that selected. Otherwise, I would have had to go into the Cloud Console and manually enabled it. So I'm going to continue. So at this point, we get some authentication tasks here. So creating a service account and downloading the key. I already did this before the demo, so we can skip that step now. I'm going to accept that. So it's enabling the API on the cloud platform right now. We get a prompt here confirming that the library was added to the POM, and it's prompting me to import the changes to sync with Maven. So I'm going to import that, and hopefully everything resolves now. There we go. So just to take a look at what it did. So I've just diffed the POM. You can see that it added the right client library to my build. So now the Google Cloud Vision API has been imported. So at this point, I think we're ready to try and run the app and see if everything works properly. So I'm going to use this develop on Kubernetes run configuration here. Let's just edit it to quickly look at some of the settings that are available. So it automatically detected my Skaffold configuration. And it's auto-populated with a couple profiles. So there's always the default profile, and I also had this Google Cloud build profile available to me. Let's just stick with the default profile for now. And before I run it, just to point out, I'm pointing right now to Docker for desktop, just because I think that's an efficient way to work. So I have that selected right now. So let's run it in debug mode. This way I can preview some of the debugging features that we're going to be putting out in an upcoming release. So it's running through the whole pipeline right now. What it's going to be doing is it's going to build my application. It's going to containerize it. It's going to push it out to a container repository. And then it's going to deploy everything, apply the manifest using kube control. So a couple interesting things here to see. So it did some port forwarding for me. So you can see it port forwarded the application port 8080, which is the default port that Spring Boot uses. And also, interestingly, it did some other things here. It port forwarded port 5005, which happens to be the default debug port used by JDWP, the Java Debug Wire protocol. And it also injected this language-specific argument for me, set it up as an environment variable in the Java Tools options. And nowhere in my code or my configuration did I have to set this up manually. The plugin took care of injecting these arguments for me so that debugging will be set up. So then the Spring Boot application is loading, and it looks like it's complete at this point. So we can jump over to the web browser, and let's hit that debug endpoint. OK, so we just have a simple form to just debug and make sure things are working properly. So I'm going to select this book, Effective Java. It's probably familiar to you Java developers out there. So I'm going to select that, and I'm going to upload it. So what happened here? I got back some JSON with the features from the book, so the title, description, author, and published date. But it doesn't look like it actually got anything interesting out of the book. This just seems like placeholder text. So that's good. We can now debug the application and figure out what's going on. So let's go into our image upload controller and set a breakpoint right before it's about to call the feature extraction service and see if we can figure out why it's not getting any real data here. So the breakpoint's set. I'm going to select the same book again, and I'm going to upload it. And you can see it immediately hit the breakpoint. And again, this application is running in Docker for Desktop. So I'm going to shift F7 and step into the extract text method to see. OK, so I can immediately see what the problem is here. So it's using this test feature extraction service, which is just a stub that I made for testing purposes, basically hard coding the values. So that's not what we want. I forgot to inject the right version of the service. So let's step out of that. Let's upload this one more time so that we hit the first breakpoint. And at this point, let's cheat a little bit. So I'm going to right-click on the feature extraction service, the local variable, and click Set Value. And let's set it to the new default feature extraction service right there. So I'm going to apply that. And it's going to hot swap the changes directly into the running application. So at this point, I can step out of it. And hopefully now it's calling the Cloud Vision API, and it will give me some real information. So there we go. So this looks a little bit better now. We got some information back from the book. We got the title, the author, and the published date. And just for debugging purposes, I'm showing an annotated image with the bounding boxes for the features that it found. What's happening is it's basically just using a simple heuristic to find the title of a book and then calling out to the book's API to get the remaining information. But it looks like we still have a little bit of a problem. The description here is null. So let's go back and see if we can debug that. So I'm going to go into my default feature extraction service and go down to where it's pulling that description. So right here. So it looks like it's pulling the description from this volume info object. So let's upload one more time. So this is the original breakpoint. Let's step out of that. There we go. So now let's open the expression evaluator really quick. And let's look and see what's inside of volume info. So volume info is calling get subtitle. And indeed, you can see it's returning null. So let's look and see what else is available here. So it looks, immediately I see get description here looks like the one we should have been using all along. And we have the real information here. So let's fix that. So I'm just going to fix it really quick. And at this point, I could wait for everything to rebuild and redeploy, but that's longer than I want to wait. So I'm just going to do Control-Shift-F7 now, or sorry, Control-Shift-F9. And what that's going to do, it's going to recompile just this class, and the ID is going to detect that the class has changed and prompt me to reload them. So I'm going to say yes. And so now these changes were live reloaded into the running application. So now at this point, I should be able to do one last test and verify that everything is working. And of course, we still hit the breakpoint. And there we go. So now we have all the information that we need, and we should be ready to push this application up to the QA environment to test the end-to-end integration. So let's go back. So I'm done with developing right now, so let's kill this. And now we want to push this up to the QA environment. So I'm going to switch from Docker for Desktop and point to my QA cluster. And if you recall, I mentioned that we have these two sets of Kubernetes manifests. And currently, the QA manifests are not properly wired in, so we can do that really quick. I'm going to open up the Skaffold YAML. And the way we're going to do this is we're just going to add a new profile to point to the right manifests. So I'm going to use the editing support. So let's add a new profile, and let's call it QA. And we're going to override the deployment configuration. And we're still going to use kube control here, but you can see that you have some other options here, some other deployment strategies. If you're using Helm or Kustomize, you can use that. So I'm going to select kube control, and then manifests, and then point to my web QA manifests. So that looks good. And now I'm going to switch over to the deploy to Kubernetes run configuration. Let's edit it. So it's still pointing to the default profile, but it automatically detected that I created a new profile, so I'm going to select it. And let's choose to tail the the logs after deployment in case something goes wrong. So I'm going to apply that, and I'm just going to run the single deployment. So it's kicking off the pipeline right now, building everything, pushing it out to a container registry, and deploy my application. And while that's running, just to point out, you may have noticed that there's no Docker file here anywhere in this project. And that's because I'm using the tool called Jib, which I explained a little bit about earlier. You can see here I'm using it in the form of the Jib Maven plugin. And it's as simple as this. It gives you a lot of configuration options, but getting started is just as easy as dropping in this Maven plugin. And that'll containerize your application efficiently without needing Docker and without even needing to write a Docker file. So let's check on the status of our deployment. It looks like it's already complete, so that's good. Then now let's jump over to the QA environment. So here we are again. I'm going to choose to add a book, and I'm going to use this AutoAwesome feature that Ian talked about. Now let's choose the same book as before and save it. And so hopefully now the bookshelf application is going to be calling out to my image recognition service. But of course, we got an error because this is a live demo. Let's try one more time.
Forgot to change test to default.
Oh, right. Thank you. So remember that I had that injection issue where I was injecting the test stub version. I forgot to swap that out because we live reloaded it.
That's how you know it's live.
So thank you, Ian, for catching that. So let's open up the controller really quick. And here we go. Let's swap it out to the default service. Perfect. So at this point, I should still be using the QA profile. And let's redeploy again. So this should be pretty quick. So it's going to build my image. Looks like the build was successful, and the deployment was complete. So now the Spring Boot app is starting, and it should be done in any second now. There we go. All right, let's test that out one more time. Let's add a book. Oops. Select effective Java again, and save it. There we go. This looks like it's taking a little longer now, so it's hopefully calling out to the right API, and there we go. We've extracted all the features from the book image, and we didn't have to type anything. So I think we're happy with our application right now. Everything looks good in the QA environment, so I'm going to hand it back to Ian to show you some more cool features in VS Code.
So that's a good thing if you guys realize how fast that second build was. That was Jib, right? So that was considerably faster than the first time because Jib is able to rebuild the image for you faster with the existing pieces of Docker files or Docker.
It granularly layers the image so that it only needs to rebuild the image, the chain. So it splits up your Java application into its dependencies, resources, and your source files. And only the layer that changed gets rebuilt. So obviously that leads to much faster container builds.
Can we go back to demo 1, please? Cool, just like that. All right, so Etan and I have talked through a lot of the developer story for everyone, and you've seen the developer inner loop and debugging and how simple we can make that for you. So we're going to touch a little bit right now on what will be provided for the DevOps side of things, looking at your Kubernetes cluster and working with some YAML. So we're going to jump right into it. So here we have this contribution here on the bottom left, and we can see here we have a couple of explorers. So the bottom one, we have a Google Kubernetes Engine Explorer. And this is a pretty simple explorer. It has my account, and you can see here the project, Google Cloud project I'm using, as well as the clusters it has. The Explorer itself is pretty simple. It gives you some creation time, some public endpoints, the status of it. But what the real power here is I can right-click and set as active cluster. And that bumps it up to my cluster explorer. And that's this explorer up here. And this is where we have all the great features. So right now you can see here I have the QA and my dev cluster. And I'm going to go ahead and I'm going to expand my QA cluster. And we're going to see some information. So I'm looking at the default namespace right now. Everything we did, we worked in our default namespace. And we can see we have our deployments, pods, services, even some custom resource definitions. And we can do this for any namespace we have. So if we go ahead and look at our deployments, you can see here we have our 3 deployments deployed right here. The bookshelf front-end and worker, as well as that image recognition service. So if we looked at my dev cluster, for instance, we wouldn't see that image recognition service, which is why my original test failed. So we can go ahead and dive into this a little bit deeper. We can see here our bookshelf front end. It gives us the desired replica counts. We can see here this little green dot in the corner here. I don't know if it shows up on that screen as well, but that's just kind of the state of everything. If it's green, everything's good. If there's some issues, we'll show a little yellow icon there, and you can dive and look into it. And if there's something that's going wrong, you can definitely go ahead and take a look at your events. So these are events from the last 24 hours. That a lot of the times, if something's going wrong, you can go ahead and look at that, and you can see some of the issues just like that from your IDE. So I'm going to show you one cool feature here. So if I'm just playing around on a test cluster or dev cluster, definitely don't suggest doing this in production, but I want to view or edit my YAML. Say I want a couple more replicas. I can just go right here, and I can pull up the YAML from the server. So this isn't my local YAML, this is my server YAML. And I see here I've got 2 replicas. I changed my mind, I want 3. I'm going to save it, and it asks me if I want to apply this configuration. Again, not necessarily best production practices, but something you can do if you're playing around. You hit yes, and just like that, we can go back to our cluster explorer, and we've got 3 replicas. So we can easily change and modify the state of our Kubernetes clusters and applications just from the IDE. We can also look a little bit more into our pods to get some more diagnostics about the application we're working with. You can see here, now we have 3 front-end workers because we just added one. We also have our bookshelf and the image recognition. And from these, we can go ahead and view and stream logs. So if I want to view logs, I can see the logs that came from this pod. And we can see here we had a couple requests to this, so there wasn't too much traffic sent to it. But we have our post and our git. And we can kind of see what's happening there. And if we want to dive a little bit deeper, we can see here's our bookshelf application. I can even get a terminal into that pod, into that container. And you can see here, I'm just going to do a quick ls. And you can see here all these files here is basically just what I had in my Explorer here. And it enables me to be able to dive a little bit deeper into what's happening and be right where my application is running. So we go back to our Explorer here. We can, of course, take a look at our services, replica sets, config maps. But we're able to easily see the state of our applications, dive in, and change them a little bit if we want. So onto the YAML, the set of features we have for our YAML. So we know that YAML is a little bit difficult. There's a lot of it. When you start using Kubernetes, maybe you add it on Knative and Istio and Kustomize, and now you just have piles of YAML. And one of the things we wanted to try and do was help make that experience easier for the user. So right here, this is our, our deployment. It's a bookshelf worker deployment. You can see here, whenever I want to see what's going on and see what one thing is, I can never keep these in my head. So a spec. What's supposed to go in a spec? There's quite a few things here. So we just on hover, give you the ability to see all the definitions and potential fields. And we can do this for any of these, and they'll give me an idea. It should be a string. It gives me a short description. And on top of that, since we know that information, we can give you some completion. So if I want to add something, I can get a list of all the possibilities here, as well as the definitions for them. So I know what I'm adding and how I'm adding it. And again, we can do some even more smarts. We know that a replicas is probably going to be an integer. If we hover over this, I'm guessing it'll tell me it's an integer. And say we go ahead and change this to cloud code. Cloud code should not be a valid set of replicas. And we can see here we're getting an error. It's incorrect type. And so we can do some type checking to help you a little bit along the way. And of course, VS Code will give us these nice red not happy path. We can change that back. And so one of my absolute favorite things that we can do here in our YAML is we have some insight into what's happening at the server or local level. So you see here we have a config map defined at the bottom. And you see it, there's a little hover above it that says created 4 days ago. So the first time this was created on my cluster was 4 days ago. And I can dive into this a little bit. So it's a config folder. It's named config folder. And I can peek the definition of that. And what happens is I pop up a window here. And you can see here, this is the local definition of this on my machine. So I can see my config map is here. The name is config folder. This is what we peek the definition of. And then I have a project ID, which is my Google Cloud project ID. And if I want to see what's going on again with this at the server level, I can go dive into that too. And so here's my server version of it. This is what's on my active cluster right now. And I can look into this. We can see Skaffold adds some labels when it does its deployments. We can see our last applied configuration. And we can even, if we go back to our local file, I want to make some changes, I can just go ahead and click onto that, and it takes me right to my code, or to my YAML in the IDE. So I'm more easily able to work with my YAML and navigate around it. So these are all of the features we have here for you on the DevOps side of things. If you want to see a little bit more about this later, we have another talk coming up we'll tell you about that does a much deeper dive into some of these features.
Let's just quickly recap what we just saw. So first we worked on the Bookshelf application, which was a 2-service app, had a front end and a back end. And we saw how easy it was to set up this local development workflow, this inner development loop. With a single click, we were able to set up this development workflow where the extension would monitor for changes in your source and then surface them live on the cluster. And remember, the application was running on GKE in that case, on Ian's dev cluster. And you also saw Ian, with a single click, attach a debugger to the application and step through it. And it behaved as if the application were running locally. It was just as easy as that. We then switched over to IntelliJ to build the image recognition service, which happened to be in Java. We showed you much of the same functionality for the inner development loop. Additionally, we showed you debugging the application, which was running in Docker for desktop, and making changes to a class file and then live reloading them, hot swapping them right into the running application, drastically reducing the iteration cycle time. Next, we showed you some ops types features. So digging into your cluster, looking at your pods, seeing some events, streaming logs from containers, viewing remote YAML, that kind of thing. And lastly, we showed you some functionality, some editing support for dealing with all of your YAML configuration. So what's next? Well, first, we would love for all of you to try out these tools and file issues if you find them on GitHub and make feature requests. And we plan to continue building out our Kubernetes support. So more direct support for tools like Helm and Kustomize in the plugins, and more support for Google Cloud Platform products, like integrations with things like Cloud Build. At this point, you might be wondering how to get your hands on these tools, and Ian will tell you.
Cool, thanks, Etan.
Yeah.
So the good stuff, how do we get to it? So we've got the Visual Studio extension, Cloud Code for Visual Studio Code is in the VS Code Marketplace. You can go ahead and download it. Cloud Code for IntelliJ is in the JetBrains repository, plugins repository. And we have our documentation, cloud.google.com/code. That QR code will take you straight to the docs. And from our docs, you can get linked to our issue tracking, feature requests, things like that. And I want to stress what Etan said is if you have feature requests, ideas, thoughts, please go ahead and leave them for us. It's a new product. We're still developing it. And we're building it for you, for the developers, for the DevOps. So we want you to be happy with the product. We want you to have the features in it that you want to be successful in your jobs. So we greatly accept feedback. So back to Etan.
Great. Well, thank you, everyone. That concludes our talk. We have some related talks that we can recommend if you're interested in diving deeper. Ian mentioned the first one, Dead Easy Kubernetes Workflows with VS Code, which will dive a little bit deeper into these workflows using the VS Code extension. It's tomorrow at 11 a.m. if you're interested in that. And we have another talk that we can recommend that will show you a little bit more with the Google container tools that we have available and working with Cloud Build. And that's also tomorrow at 11 a.m. And we have our information up here, so if any questions come up later, feel free to reach out to us, and we'll do our best to get back to you. And thanks, everyone, for coming.
Yeah.